Very good morning, student. Now we'll continue the chapter 5. Now we'll continue the chapter 5, now which is in that chapter 5 which we already completed, the controllers, compensators. Okay. Now in the same chapter then we will see the another topic which is the state space analysis. Okay. So in the GATE examination, the state space analysis, definitely there are 2 marks in the GATE examination. Okay. In the state space analysis topic, there are 2 marks in the GATE examination if you take up for the past 10 years papers. Okay. Now in that, in a GATE paper, some linked answer questions are there. In that linked answer questions means now question 1, after solving question 1, that answer is used in question number 2. That is a linked answers question. Okay. Now in that linked answers question, definitely one of the question is from the control system, and that control system and the topic is this, the same topic, fixed topic. Okay. For the past 8 or 10 years, if you take the same question which is repeated, means the same question means in the same topic. Okay. So that's why this is very important and very easy, very interesting also. Okay. So now we'll see what is a state space analysis. Now you tell me what is a state, how you can define a state. See, the state is nothing but the state represents the future behavior of the system. The state represents the future behavior of the system. Now you tell me, now let us take your future. Now your future is depends upon what? Now similarly, the state represents the future behavior of the system. Now the future behavior is definitely depends upon present input. The future behavior is definitely depends upon present input and past history of the system. The future behavior of the system is depends upon present input and past history of the system. Now this past history of the system, is described with state variables. So if you want to remember the past history, you want to have a past history, means we want to store that past history. So to store this past history, so we requires a memory, right? Now the past history of the system is described with a state variable, and this past history of the system is to require the past history, we require a memory element. Okay. Now let us take one small problem you can easily understand. Okay. Now let us start here. Now this is one electric circuit. Now see here, now these are the 3 electrical circuits. Now here no state variables. How I can say? The fast history of the system is deals with the state variable, described with the state variable. Now to require a fast history, we need a memory element, memory device, okay? But this is a resistor, it's a dissipative element. This is not a storage element. These are not the storage element. Therefore, there is no state variables, and this is called as memoryless system. Is it right or not? Right? Now, because this output is completely depends upon the input only. So, this output is completely depends only on the input. But our output, our future is depends upon input and fast history. Fast history means we require some storage element. So, is there any storage elements here? Yes. Therefore, here one state variables. One state variable. Now, one state variable, let us take the state variable is x1. Now here, inductor and capacitor. There are two state variables here because two storage elements. Two state variables. Therefore, x1 and x2. Now there are two state variables. Clear or not? Then what you can understand? So now this is the electric circuit, this is the electric circuit, this is the electric circuit. Now there are three electrical circuits which are given to you. Am I right or not? Now when there are three electrical circuits which are given to you, so and you identify the number of state variables, now the number of storage elements will give the number of state variables. So what should be the conclusion here? If in electric circuit is given, so I want to write one point. What is the point? If electrical circuit is given, number of state variables will be the number of storage elements, or the number of state variables is nothing but a sum of the inductors and capacitors. Only one capacitor, one state variable. Sum of the inductors and capacitors are two, therefore two state variables. Okay. Now this is the way you can identify if electrical circuit is given, the how to verify the number of state variables. Understand or not? So this is the number of state variables if electric circuit is given. Okay, just note down this, students. Okay. Now this is the way we can identify the number of state variables if electrical circuit is given. Now see here. Now let us see. Now if differential equations and transfer function. If differential equation and transfer function is given. Now let us check here. D square y by dt square plus 6 into dy by dt plus 3y equal to 2u. Now d cube y by dt cube plus 8 into d square y by dt square plus 7 into dy by dt plus 8y equal to u. Now this is the differential equations. Let us check. Okay. So what is this order of the differential equation? Now here it is order 2. Now what is the order of this differential equation? Now here it is order 3. So here order is 2. Therefore there are two state variables x1, x2. Here order is 3. Therefore, three state variables x1, x2 and x3. If order is 3, three state variables. Order is 2, two state variables. Okay. Now see here. Now this is the order differential equation. The order is nothing but the number of state variables is nothing but order of the differential equation. So if differential equation or transfer function is given, so whatever it may be the order, that will give the number of state variables. Okay. Now for example, let us take here. Now this is the transfer function. Now this is the transfer function. Now see here. Now what is the order of this transfer function? 2. So which means that order equal to 2. Therefore again two state variables x1 comma x2. Now here order is 3. Order is 3. Therefore three state variables x1, x2, x3. Therefore now if differential equation or transfer function is given, if differential equation or transfer function is given, order will give the number of state variables. Order will give the number of state variables. Understand? So whatever may be the order, then that will be the number of state variables. If differential equation or transfer function is given, then how to identify the state variables I am saying. Okay, note down. So this is the way. Now first we want to identify the number of state variables. Now this is the future behavior of the system. the future behavior of the system is nothing but output. The future behavior of the system is nothing but output or future behavior of the system. Now this output or future behavior of the system is represented by y of t, and this is the present input. Now this input is represented by u of t, and this is the past history of the system. The past history of the system is described with state variables. Now the state variable x1, x2, x3, so this is nothing but state vector x of t. Now this x of t consisting of x1, x2, x3 and so on. So this is the past history of the system. So the output, a future behavior of the system is y of t, input is represented by u of t, and the state vector is represented by x of t. So then I just give a multi-input, multi-output system. Multi-input, multi-output system. If I take now n inputs, u1, u2 and so on, un. Multi-outputs, y1, y2 and so on, yn. Multi-input, multi-output and state variables x1, x2 and so on, xn, n state variables. Okay, so inputs represented by u of t. Now this is outputs represented by y of t. Now these are the number of state variables. Now this is represented by x of t, state vector, and which consisting of state variables. Okay, now this is the multi-input, multi-output system. Now this is nothing but the state space model. This is nothing but the state space model. So our job is first to find the state space model. Okay, now how to find the state space model? Now he may give the electrical circuit, he may give the differential equation, he may give the transfer function, he may give the block diagram, he may give the signal flow graph. Then from those equations, from those relations, then how we can find the state space model. Okay, now you just forget about the state space analysis. Now first we concentrated on state space model. Okay, I want to concentrate it first on state space model. How to get the state space model? Sir, then what is the meaning of state space model? Sir, the state space model is nothing but this box? No. The state space model is nothing but the state space model consisting of two equations. One is state equation. One is state equation and second one is output equation. The state space model consisting of two equations. One is state equation and the second one is output equation. Okay, so first we want to find the state equation. First we want to find the output equation. Once if you have a state equation, once if you have an output equation, then the state space model is available with you. Okay, so now we will see first what is the definition of state equation and what is the definition of output equation, how to find the state equation and how to find the output equations from the different approaches. Okay, now we'll see. First you note on this. In this state space analysis, now first we will try to concentrate it on state space model. How to find the state space model? Now this is the state space model. and I am already saying that this state space model consisting of two equations. One is state equation and another one is output equation, right? One is state equation, another one is output equation. Now this is the state space model. The state space model consisting of two equations. One is state equation and another one is output equation. Now state equation. What is a state equation? What is the definition of state equation? Now see here, listen carefully, okay? Now the first derivative of state vector, see, the first derivative of state vector, first derivative means dx of t by dt or x dot of t or x dash of t. All these are the first derivative. Listen carefully, okay? Now I am giving the definition as well as writing. The first derivative of state vector can be expressed as a linear constants of state vector and inputs. One of the linear constant is a, another linear constant is b. I am taking. Now this is nothing but state equation. This is nothing but state equation. Once again I am repeat, listen. First derivative of state vector. The first derivative of state vector can be expressed as a linear constants of state vector and input. That's it. So whatever he is given, so you want to find the state equation, right? Next one is output equation. So output equation is also very simple. You know that. Now you tell me, for a control system, output depends upon what? Output depends upon always input and controlling actions. Now similarly, for a state for a state space model also, output equation, output depends upon the state vector and inputs. So what is the output equation? So the output equation is output at any instant of time, output y of t, output at any instant of time can be expressed as a output at any instant of time can be expressed as a linear constants of state vector and input. Linear constants, one of the linear constant is c, another linear constant is d. Now output at any instant of time can be expressed as a linear constants of state vector and input. Now this is the output equation. Output at any instant of time can be expressed as a linear constants of state vector and inputs. Okay. Now this is the output equation. This is the state equation. So if you find the state equation, if you find the output equation, then you can easily have a state space model with you. Okay. Now we will see one by one how to solve, how to find the state equation and how to find the output equation from the different approaches. Okay. Now first you note down this. Okay. The first derivative of state vector can be expressed as a linear constants of state vector and input. This is the state equation definition. Output equation. Output at any instant of time can be expressed as a linear constants of state vector and input. This is the output equation definition. Okay. Right. Now I will write one by one. First, we want to find state equation and output equation. Now what is given? From differential equation. From differential equation, how to find the state equation, how to find the output equation, which is nothing but from the differential equation, how to get the state space model. The state space model is nothing but finding state equation and finding output equation. Okay. Now this is from differential equation, then we will see. Okay. So let us take one small example. Now this is the differential equation which is given to you. D square y by dt square plus 6 into dy by dt plus 3y which is equal to 2u. So this is the answer. This is the question which is given. Differential equation is given. Now you want to find the state equation. Now you want to find the output equation. Then there are two steps. Okay, first you remember. Now what is the first step? And I am already explained n number of times. Now this is the differential equation. You must and should see the order. What is the order? Now this is the second order. Now order is nothing but the number of order is 2. Order is 2. You know that order will use the number of state variables x1 and x2. Order will use the number of state variables. So order is 2. Therefore number of state variables are 2. Right? So this is order. Order will use the number of state variables. Order is 2. Therefore 2 state variables. Next. Solution starts with y equal to x1 if differential equation is given. Solution starts with y equal to x1 if differential equation is given. Solution starts with y equal to x1 if transfer function is given. Same, okay. First you find the order. Next you identify the number of state variables. We'll use the order. Once the order is completed, then your solution should be starts with y equal to x1, whether it is a differential equation or whether it is a transfer function. Okay. Hold on. Now see here, then we'll do the same procedure. Now solution starts with y equal to x1, but I want dx by dt, right? First order differential. Okay. Now this is the first derivative of the state vector. So dy by dt, which is equal to dx1 by dt, which is equal to x1 dot. Okay, x1 dot. Now which is equal to, can I take a variable x2 and assign to x1 dash? Okay, because I want x1 dash equal to something, x2 dash equal to something like this. Okay, so next d square y by dt square, which is equal to d square x1 by dt square, which is equal to x1 double dash or x2 dash. So can I take a variable x3 and assign to x2 dash? This is wrong. Now why this is wrong? Why this is wrong? Because only two state variables, x1, x3, but how you can get x3? This is wrong. This equation is wrong. Understand or not? Yes. So then how I can find? You stop only x2 dash because only the state variables are x1 and x2. Only two state variables. So x2 dash you stop. So then how I can get x2 dash? Take this equation to the right hand side. So now see here, d square y by dt square, which is equal to minus 3y minus 6 dy by dt plus 2u. So this is d square y by dt square means x2 dash. Now this is x2 dot, which is equal to minus 3y minus 6 dy by dt is nothing but x1 dot plus 2 into u. If you write like this equation is also wrong. This equation is also wrong because this equation is wrong because now see here, the whatever the state equation is saying, you strictly follow the state equation rules and regulation. What is the state equation is saying? The state equation is saying the first derivative of state vector, the first derivative of any state vector or any state variable, again you cannot express in the derivative of state vector and you cannot express in the output. But how you are expressing here? The derivative of state vector is expressed in terms of output. But the state equation is saying, is there any output in the state equation? No, but why you are writing output? That is the reason why this is wrong. And the derivative of state vector or a derivative of state variable, again you are not expressed in terms of derivative of state vector. Derivative, again you expressed in terms of derivative is wrong. But derivative of state vector may be expressed in terms of input. Okay, this is acceptable. This part is acceptable, but this part is 100% wrong. Understand or not? Whatever the state equation is saying, you strictly follow the rules and regulations of the state equation. Whatever the equation is saying, you follow blindly. If you find anything against this equation, then that is a wrong analysis. Okay, so how you can make it a correct? So this equation you can make it correct. X2 dash, which is equal to minus 3. Y is wrong, but in place of y we can write x1. Yes, derivative is expressed in terms of state variables with constant. State variables with constant, correct? Minus 6. X1 dot is wrong, but in place of x1 dot can I take x2? Yes. So the derivative of state variable expressed in terms of state variables with constants or constants with input. Now this equation is 100% right. These are the correct equation and this is the correct equation. Okay. So there are two state variables. Therefore, there are two state variables. First derivative are these two. Okay. Enough. Therefore, now see here. Now how I can write? You just listen carefully. Now this is the first derivative of state vector. So here x1 dot x2 dot over, now which is equal to, now this is x1 x2. So now you see, concentrate here, this is 2 by 1 matrix, this is also 2 by 1, but this should be equal and this is multiplied with some other matrix. Therefore this A is not a constant. This A is also matrix of order 2 by 2. So 2 to cancel, 2 by 1, and which is the resultant is 2 by 1. Next, plus U, only single U. U means only 1 by 1 here, only 1 by 1. So definitely the B is not a constant. B is also one of the state matrix whose order is 2 by 1. 1, 1 cancel, multiplication is possible. This is 2 by 1. 2 to cancel, multiplication is possible. 2 by 1. Both orders are same. Addition is possible and which is equal to 2 by 1. Understand? Is matching or not? Yes. Now see here. In x1 dash, x1 is there? No. In x1 dash, x1 is there? No. If it is not there, 0. In x1 dash, x2 is there? Yes. What is the quotient? 1. In x1 dash, u is there? In x1 dash, u is there? No. 0. Now see in x2 dash everybody is present. x2 dash x1 is present. x2 dash x1 is present. How much? Minus 3. x2 dash x2 is present. How much? Minus 6. x2 dash u is also present. How much? 2. So these are the state equation. Understand not? This is the state equation. This is not the constant. This is the state matrices. This is matrix A. This is matrix B. Okay. This is matrix A. This is matrix B. Now see here. Now anyway, the state equation is very important for any problem. Okay. Output equation is very easy. Okay. Now we will see the output equation here. Output. Only one output. y, only single y. Y means, what is the matrix of order? 1 by 1. So x of t is already fixed. What is x of t? X of t is two state variables, x1, x2. So this is 2 by 1. Therefore, definitely the C matrix must and should be 1 by 2. 2 to cancel. Now 1 by 1 equal to 1 by 1. Now, is there any x1 in y? Yes, y equal to x1. The quotient is 1. So 1. Now, is there any x2 in y? No, nothing is there. 0. Generally, there is no D matrix. Okay, 90% there is no D matrix because y is always 99%. It is a combination of x. If anything is there in terms of u, then you can take the D matrix also. Now, if any y equation is in terms of u, then you can get the D matrices also. But generally, there is no D matrix. If it is there, you can calculate. Okay. Now, this is another state matrix. Now, this is one of the state matrix A, B, and this is the one of the state matrix which is equal to C. Okay, note down this. Okay, this is the way you can get the solution of any differential equation of any order. So how many state variables? Solution start with y equal to x1, and where we will start. Okay, now here I will write one small important note you just observed. Now A matrix order is, A is a square matrix. Listen, A is always a square matrix whose order is n by n. So where n is number of state variables. What is that? A is number of state variables. So number of state variables is nothing but order, transfer function order, a differential equation order, or a number of storage elements. Am I not? So where A is number of state variables. Now what is the differential equation? This is the differential equation. What is the order? Order is 2. So number of state variables are 2. Therefore, for this example, n equal to 2. For example, now number of state variables is 2. Therefore, n equal to 2. Therefore, what is A matrix order? 2 by 2. If number of state variables are 3, A matrix order is 3 by 3. Number of state variables are 4, A matrix order is 4 by 4. Once the A matrix is identified, you can easily identify the remaining matrix. If A is 2 by 2, then what is B? B is fixed now. If A is 2 by 2, now the B is, tell me, if A is 2 by 2, B is 2 by 1, which means that B is n by 1. Okay, now now C is also important. Now C is always 1 by n. So that depends upon here n. If you observe n, what is n, then automatically you can find everything. Okay. So which means that C equal to 1 by 2, like this. So first you fix the number of state variables, and automatically you can easily fix the order. Okay, you can easily fix the order of the matrices. Okay, no. Now based on this, now I will tell you one easiest method to you. Okay. Now order is 2. I don't see anywhere, only this order is 2. So 2 state variables x1, x2. Order is 2 means n equal to 2, right? Order is 2 means n equal to 2. Now you just see here. What is A matrix? A matrix order is n by n. N by n means 2 by 2. This is the 2 by 2 matrix. Now listen carefully. In A matrix, last row, A matrix last row is the transfer function. Move from right hand side to left hand side. Take the coefficients with opposite sign. Take the coefficients with opposite sign. 3 means minus 3. Plus 3 means minus 3. Plus 6 means minus 6. This is the last row, okay? The last row elements in A matrix in the differential equation move from right hand side to left hand side. Take the coefficients with opposite sign. And here it is 0, 1. The first row is a fixed row. Now the first element is 0, second element is 1 in A matrix, okay? The last row is the differential equation move from right hand to left hand side. Take the quotient with opposite sign. Now, what is the B quotient? B quotient is 2 by 1. B quotient is 2 by 1. So, now see here. The last element of B quotient is, the last element of B is quotient of U. Whatever there is a U quotient, whatever may be the quotient. So whatever the quotient of U, that will be the last element in B matrix. Okay. The last element in B matrix is the quotient of U. What is the quotient of U? 2. Quotient of U will be the last element in B matrix. Remaining all are zeros. Remaining all are means only 2 by 1 matrix. Therefore this is here. And C matrix order is 1 by 2. Now this is a fixed matrix, which is first element is 1, remaining elements are 0. Now C matrix is fixed matrix. C matrix is fixed matrix. First element is 1, remaining all elements are zeros. C matrix is a fixed matrix. First element is 1, remaining all elements are zeros. Okay. Why? Because y equal to x1, the solution starts with y equal to x1. Therefore, first element is 1, remaining all elements are zeros. So this is the shortcut method to get the state space model from the differential equation. See the same answers: 0, 1, minus 3, minus 6, 0, 2, 1, 0. Same answers. Okay. This is the easiest method, no doubt.